to a new video. In this video I'm going to explain planes and vectors. I'll give an introduction to planes and vectors, the general formula of a plane, the normal vector of a plane, what does a normal vector mean, what does it represent for the plane, how to find the relations between planes if they are parallel or perpendicular or intersecting. I won't get into lines and the Cartesian parametric equations of lines. We'll leave that for another video. In this video I want to focus on planes, their normal vectors, and the relations between planes. So the general formula of any plane is ax plus by plus cz plus r equals to 0. A, B, C, and R are constants, as you can see here. A, B, and C are the coefficients of x, y, and z, and x, y, and z represent these coordinate axes that we see here, x, y, and z. So the vector n of coordinates A, B, and C is the normal vector of the plane of this equation. So we know that the vector of coordinates A, B, and C will always be the normal vector of the plane. Therefore, n is perpendicular to any line in the plane. So now we can conclude that the normal vector of a plane is basically the vector that is perpendicular to any other line in the plane. As you can see here, we've got this line over here, which I forgot to name as vector n. So this line over here is perpendicular to any other line in the plane P. No matter how we move line n back and forth or to the right or to the left, it will always be perpendicular to any other line in this plane. It will always be perpendicular to any other line. It's perpendicular to this line over here, and it's perpendicular to this line over here. So no matter how we move it, it's always perpendicular to any other line in the plane. So therefore, we conclude that the normal vector is basically the vector that is perpendicular to any line in the plane. Parallel lines have parallel normal vectors. That is something that is obvious. We used to say that when we have two parallel lines, any perpendicular to one of the lines is perpendicular to the other line. So it's the same idea for vectors. A normal parallel to another normal means that we've got two parallel planes. It goes the other way around. Two parallel planes have the same normal vector or parallel normal vectors. Therefore, vector n is equal to a constant times vector L. That means that vector n is either parallel to vector L or is the same vector L. Then we've got the plane P of equation x minus y minus 2z minus 5 equals to 0, and the line E of coordinates minus 2, 5, and minus 6. Find A, B, C, and R, and does E belong to P? Find A, B, C, and R. So this is plane P of equation x minus y minus 2z minus 5 equals to 0. A would basically be 1, B would basically be minus 1, C is equal to minus 2, and R is equal to minus 5. We simply substitute. Does E belong to P? To find whether E belongs to P or not, we can simply substitute the coordinates of E in the equation P, and we'd see that it's equal to minus 5, minus 2, minus 5, that is minus 7. Minus 2 times minus 6 is equal to 12, so minus 7 plus 12 is equal to 5. 5 minus 5 is equal to 0. Therefore, 0 is equal to 0. That is compatible. That means that E does in fact belong to the plane P. Moving on to number 2, they gave us a plane Q of normal vector J of coordinates 3 minus 3 minus 6. We can say that J is 3 times n. 3 times 1 is equal to 3, and minus 3 times and minus 1 times the 3 is equal to minus 3, and minus 2 times the 3 is equal to minus 6. Therefore, J is equal to 3n. We conclude that normal vector J is parallel to normal vector n of plane P. Therefore, these two vectors are parallel, having two parallel normal vectors. Are these two planes perpendicular? They are obviously not. They are parallel, they cannot be perpendicular. Why? We just said why. Number 3, moving on to number 3, let K be a plane of normal 1, minus 1, and 1. What is the relation between these two planes? And by these two planes, I mean plane K and plane P. So we can see that there is no clear relation between the normal of plane K of coordinates 1, minus 1, and 1, and the normal of plane N of coordinates 1, minus 1, and minus 2. K, the normal vector of K, isn't equal to isn't any product of coefficient times the coordinates of the normal vector of n. Therefore, these two normal vectors aren't parallel, but they can be perpendicular. How do we find if two vectors are perpendicular? If we had vectors u and v, it would be u times v is equal to 0. That is exactly what we do here. We multiply the coordinates of the vectors and we add them. So it's 1 times 1 plus minus 1 times minus 1 plus minus 2 times 1, that would give us 2 minus 2 equal to 0. Therefore, these two normal vectors are perpendicular. Having two normal perpendicular vectors means that these two planes are also perpendicular. That is all for planes. We said that they can either be perpendicular, intersecting, or parallel. We didn't talk about intersecting planes. We'll leave that for another video. I hope in the next video, as I said, we can get into lines and the equations of lines. Until then, I hope you understand this. I hope you enjoy this video, and thank you for watching. And any questions, please leave them in the comment section. Have a nice day.